relations are sets of ordered pairs, and ordered pairs of numbers I can interpret as the coordinates of a point in the xy plane. So that means that relations can be given to us graphically. Now, the power of graphs is that they work very nicely if I have just a finite number of points, which is what I have here. I've got 1, 2, I'm going to make that a little bit bigger. 1, 2, 3, 4 points here in this relation. But as we discussed earlier, if I have infinitely many points, I can draw infinitely many points, whereas I can't list them either in a set of ordered pairs or in a table of values. So this is the first format for a relation we've seen that would translate nicely to relations that have infinitely many ordered pairs in them. We're still working with this example where we've got finitely many. Again, I've put 2 examples up on the board, problems 5 and 6. We're going to do 5 together, and then I'll have you pause the video and try problem 6. Okay. First thing I'm going to do is just label my points. Now, I tell you in the worksheet, and I'll tell you verbally now, all of these tick marks on the axes are meant to be 1 unit apart, and all of these points have integer coefficients. Okay, now I need to tell you that because it's really hard to distinguish between something that's at 3 and something that's at 3.002. Our eyes aren't acute enough, and my drawing skills aren't good enough to be able to distinguish between those locations. But if you're told that the points have integer coefficients, then we can figure out where we are. So for this point, if I just sort of follow straight down to the x-axis, I can see that the x value of that point is going to be at -2. And then if I come straight over to the y-axis, I can see we're up at 1, 2, 3, 4. So that point would be -2, 4. I'm just going to add that to the graph. It's not part of my directions, but it's going to make the rest of the problem simpler, I think. Okay. This point here is right here on the y-axis, so we haven't gone left or right, so its x value is 0, and I can see we've gone 1, 2, 3 up. Okay. Now for this point, to figure out what the x value is, I'm going to go straight up here to the x-axis, and I can see 1, 2, 3, we've come 3 over, and then if I drop a perpendicular over to the y-axis, I can see we're down here 1 down. So that's the point 3, -1. For this point, it's directly below this point on the x-axis, which is 1, 2, 3, 4, 5, 6 over. And it's directly across from this point on the y-axis, which is 2 down. Okay. So I've written the coordinates of the point. That's most of the work that I need to do for part A. We were asked to just write as a set of ordered pairs. Now I'm just going to take those ordered pairs that I just wrote and put them inside of set braces. So -2, 4, 0, 3, 3, -1, and 6, -2. Then we're asked to find the domain. I'm going to just call that D. That's a set, and that's the set of all of the x values, or the first terms. So I can either look at the graph or I can look here. I'm going to just look at the graph. I'm going to notice that my x values were -2, 0, 3, and 6. So that's my domain. The next question we're asked is the range. I'll call that R. And remember, that's just the set of the y values. So if I look here, the y values that I had were 4, 3, -1, and -2. By the way, it doesn't matter what order I list them in, as long as it's this set or this collection of y values. So if you wanted to rearrange these to list them from biggest to smallest or from smallest to biggest, that's totally fine. It's up to you. Okay. Now, the question of, is it a function? Remember, the rule for being a function is that each input or each x value has to have a unique y value associated with it. And when we're working with graphs, there's a nifty trick for testing to see whether something is a function, and it's called the vertical line test. This is it a yardstick or a meter stick? It's a yardstick. This yardstick here is going to represent my vertical lines. Now, if I put the yardstick down here, right now, 1, 2, 3, 4, Right now, this is marking off every single point on the plane whose x value is -4. So I came over to -4 on the x-axis, and then if I go just straight up or straight down, that spells out this vertical line. That's every single point whose x value is -4. The equation of that line would be x equals -4. Now, there weren't any points on my graph where x was -4. But if I come over here to where x is -2, there is a point on the graph. But you'll notice there's only one point there. That means that's the only point in this relation that has an x value of -2. And if there's only one point, then there's only one y value associated with it. If I had another point right here, let's say I had this point -2, -1, then notice when I draw my vertical line, it's going to intersect the relation at two different points, up here and down here. That shows me that there are two different points that have the same x value, but obviously if they're different points, they've got different y values. That would make this not a function. Now I don't have that point, so I'm going to go ahead and erase it. But if I move my vertical line to put it at different locations, a lot of times it doesn't intersect the function at all, because there are only 4 different x values where I have a point. But here, when x is 0, there's only one point on the vertical line whose equation is x equals 0, so that means there's only one y value associated with that x. And no matter where I put this vertical line, it never intersects the relation more than once. Sometimes there are no points on it, sometimes there's just one, but the answer to whether this is a function or not is yes. And the reason is it passes what we call the vertical line test. And what that means is that no vertical line intersects the relation more than once, or intersects the graph more than once. So that's a very useful visual tool we have, and as you're doing that at home, you probably don't need a yardstick. If you just have a pencil, you can use your pencil as your vertical line. Just take your pencil and sort of slide it along. If at any point it intersects the graph of the relation more than once, you've just failed the vertical line test. It's not a function. On the other hand, if there's no vertical line that intersects the graph more than once, then your graph is the graph of a function. Okay, so that's problem 5. At this point, pause the video, try problem 6 on your own, and then tune back in to check your answers. All right, so I've got the answers to question 6 on the board. Again, I chose to just label the coordinates of the points here on the graph, and then for part A, we were just listing those 4 points and putting them inside of these set braces. Once again, it doesn't matter the order in which you listed them. As long as you have these 4 points inside of set braces, you've done part A correctly. Our domain was the x values, that's -4, -2, and 3, and our range was the y values 5, 0, 2, and 3. Okay. Part D, this is not a function. Now, I might just see that from looking here and seeing that the x value of -4 has 2 different y values associated with that. But if I use this vertical line test, notice here's the vertical line where x is -4. This picks out every point on the plane with x being -4. Since there are 2 different points here, but they have the same x value, if they're different points, they have different y values. So we've got 2 different y values associated with the same x, and this is not the graph of a function. It's still a relation. It's a set of ordered pairs, but it's not a function because it fails the vertical line test.